an issue. Questions on that? So, this is the first three. What information do I need to know to do number one? Anybody that did that or wants to learn how to do it, what information do I need to do to get to moles? So I have to have a relationship between grams and moles. Okay? So what information do I need to get to that point? Anybody? Yeah.
Is it the atomic weight need?
Right. So the atomic weight is the same as the molar mass. So if it's aluminum, we got this number on the periodic table. It's 26.98, right? Grams per 1 mole. Any questions with that? So you just look that one up. So anytime you're given a weight, or you're asking for a weight, like these first three, guess what we're going to look? We're going to look on the periodic table. Does that make sense? So, and we're going to look for that particular element. So aluminum, cesium, and hydrogen. So we're going to have to use that weight somewhere in the problem. This is my conversion ratio. All right? So I'm going to take the 410 grams of aluminum. There's my conversion ratio. Grams go on bottom, and moles go on top. So every 1 mole, you have 26.98 grams. Any questions with that? And the answer for that was 15. How'd you guys do on that one? Good? Thumbs up? Okay. So the next one's the reverse of that. So anytime you got grams, or you are asked to find grams, or you're given grams, you got to look up on the periodic table. So you would look up cesium. Cesium is 132.9055. Okay? So on that one, I'll put the 0.050 moles. And then down below, I'll put moles of cesium. And then what goes up above? Grams of cesium. So then, so I don't get myself in trouble and copy exactly what it is here, I just put my units in there. So it said for every 1 mole, I'm going to have 132.9055. Okay, and I multiply that out, and I get an answer of 6.6. Any questions on that? Yes?
For this in general, I for like one step up like this, I did cross multiplication and division, and I got the same answer.
Right. Okay. I'd accept that, but here's the issue with that. And that's fine on one-step problems, but what's going to happen?
Right. Well, I totally get that.
We're going to start getting into multiple-step problems, so if you do it that way, you're going to have to do the cross-multiplication, get an answer, do another cross-multiplication, get an answer.
I was just wondering if you accept that.
I'd accept that.
Okay.
But I'm just saying that you don't want to do that because there'll be so many of them that we'll do that for. Okay? Questions on those first two? All right? All right, the next one. Carter, you watching up here? Okay, good. Like to hear that. So, the next thing, we got number 3. Now, that's a gram one also, and it's hydrogen. And hydrogen's 1.0079. Guys, if you want to, you can round it to the nearest hundredth spot. So 1.0079. And why do we do this? One reason is because a lot of times you're not going to need no more than 3 significant digits in an answer anyway. If you want to write it all out, you can. Like this one would probably be best to put down for cesium 132.91. Okay? You could probably get away with saying 132.9. Okay? So there's 1.01 grams of hydrogen to 1 mole. Now, if you didn't do that problem, do it. and see what you get. So if you didn't do that problem, I'll give the answer to you. For those who did it, the answer to that problem is 1.21 times 10 to the 4th. Okay? Or 12,100. Okay, so I'm going to give you just a minute if you didn't do that setup, do that problem. Go ahead and set it up and then see what your setup looks like. Yes?
So do you want our answers in scientific notation or how do you want us to?
No, it's really all up to you, and I accept either one. Unless it gets to the point where, like on problems, problem number 5, you have to put it in scientific notation. So you get to problem number 5, you have to have that in scientific notation.
What was the answer?
The answer for that one I came up with was 1.21 times 10 to the 4th.
Okay.
Is that what you got?
Yeah.
All right, good deal. Most of these are one-step problems. Okay? That's not going to always be the case. But most of the simple ones we start out with would be one step. So we got 1.20 times 10 to the 4th moles of hydrogen. Then the setup would be moles of hydrogen, 2 grams of hydrogen. And that's 1.01 grams for every 1 mole. And then that's where we come up with that answer. 1.21 times 10 to the 4th. And if you want to put it in normal form, it'd be just 12,100. Questions to this point? So, those first 3 was dependent upon you looking up a molar mass. Okay? Okay. So, questions that you have. Okay, Reagan, we're just going through the assignment and checking the answers out. Now, on these last 2, you've got to use this number. So on the last 2, it's asking for, it's giving you atoms, and it's asking for atoms. So in both of those examples, you're going to have to use this number somewhere in there. All right? So this number is atoms to moles. So that number says 6.02 times 10 to the 23rd atoms. Like a dozen's 12, that's going to equal 1 mole of atoms. So on this first one, I'll put this number out in front. And that would be calcium atoms. So if you get stumped on these, what do I always tell you to do right away? What goes down here?
CA atoms.
CA atoms, right. Ava. You just copy that because you know you got to get rid of it. So what number goes in there? Anybody know? No. Not 1. Atoms. Here's atoms. So it'd be, doesn't matter if it's calcium, strontium, whatever, that would be 6.02 times 10 to the 23rd. Then what are we trying to find? Moles. There's moles. So 1 mole of calcium. So we take 7.35 divided by 6.02, okay? And when we do that, we get an answer out that is 1.27. But that's not my final answer because I've got scientific notation that I've got to deal with. So would you subtract or add these two?
Subtract.
So 24 minus 23 is
1.
1. So it'd be 1.27 times 10 to the first, or 12.7 moles. So either one is fine that you have. Questions on that? So, I'm going to have you do this last one because I know a lot of you missed it. So, we're going to start out with 70.3 grams of strontium. Okay? Now, what's the connector between grams and atoms? What unit?
Mole.
Moles. Good. So down here I put grams of strontium, and up here I put moles of strontium. Okay? So then the next step would be what?
Moles to atoms.
Very good. Moles of strontium to atoms. You guys go ahead and put in the numbers and then calculate it and see what you get. So take a couple minutes to do that one just to see if you're able to come up with the right answer. 80.
Oh, because that's, okay, yeah.
7.62 grams to 1 mole. Because on the periodic table, if you would weigh out that many grams of strontium, you'd have 1 mole of atoms. Now, 1 mole of atoms is equal to a count. So both of these represent a count. Moles and atoms, like dozen and 12. They both and the reason why we have both is because mole is a much easier value to deal with when we're dealing with atoms. Okay? So that would be 1 mole is equal to 6.02 times 10 to the 23rd. And that would be your setup. So, what I would do, I'd take 70.3 divided by 87.62, press equals, multiply by 6.02, press equals, and when I do that, I get an answer that's 4.83. Okay? So then what's my exponent going to be? Times 10 to the 23rd. Easy. Easy peasy. And that would be atoms of strontium. So, based upon chapter 1 and 2, where we deal with scientific notation, these would be pretty easy. Look at this, how easy this is. 24 minus 23. It's a 1. Okay? There's no other exponents in there, so just 23. You do not have to change this to scientific notation. I know a lot of times students would take these numbers and change them in scientific notation. Don't do that. Just use the normal form. Then you're just going to add on your exponent, and you may have to change it depending upon the decimal, where the decimal is placed. Questions on those? So here's what I'm going to do. A lot of you were not given credit on that, so if you want credit, you don't have to do these, but if you want the credit, you can show me this on Thursday. Okay? So this is not an assignment. If you got your assignment done and you showed the work, you're credited 100 points or 10 out of 10. If you don't have any work shown, you have numbers, just put in those spots. I'm not accepting it. Okay? You got to show. So if you were gone yesterday, this is your assignment from what they did. Okay? So I'll leave that up there for you, and then we're going to probably take about 10 minutes to talk about a really similar concept to what we've already went through. Easier even of what we did for today. Okay? It's even easier than this. Okay. So, if you didn't understand what you're doing, hopefully now, seeing those 5 setups, how they're set up, now you can do these 5 and have confidence in doing them, and probably take you 10 minutes to do. Yep.
Is there a decimal between the number 4?
No. 1,200 grams. If you do make a mistake on these and you put a decimal there, I'm it's a completion. It's not like I'm counting it. So if you accidentally put 12.00, then don't worry about that. So these are what we call chemical formulas, okay, of compounds. And they're a combination of elements that go together in a particular way, in a specific way. Dalton's atomic theory said what? That when atoms go together, they go together in specific, definite ratios. So what's the ratio of carbon, hydrogen, and oxygen here? 6 to 12 to 6 is its ratio. Okay? So, we have this idea of a mole. So we have a mole of this compound. Alright? And if we have a mole of this compound, then we've got these subscripts. And those subscripts will give us an indication of how many atoms are in that compound. So, how many atoms do we have? If we have one molecule of this, how many atoms are carbon in that compound? How many atoms are carbon? If we have one molecule of that, 6. Does that make sense? How many atoms do we have of hydrogen? 12. Don't get much easier than that. And then how much for oxygen? 6. Okay? So, if I have a mole out in front, that is a lot more atoms. So, how many moles of carbon atoms do I have here? I have 6 moles. Does that make sense? How many moles of hydrogen do I have there? 12. How many there? 6. Okay. So let's get something tougher. Let's do this one. Okay? So now we've got something a little bit tougher because we've got this parentheses. So that's like this in math. That's kind of like that 2 outside. So in math, your teacher's going to say, what do you need to do with that 2? Distribute it. What do you need to do with this 2 here then, if we're counting moles of atoms? Distribute it. So how many lead moles do we have here? 1. That 2 only goes with what is behind, directly behind. So I have 2 lead, or 1 lead. How many nitrogens? Everybody see there's 2?
Yep.
Okay, because it distributes through 2. And how many oxygens? 6. Right? Because when you multiply, this would be 4x and 6y. Right? So, 2 nitrogens, 6. So it multiplies. Okay? So, how many nitrogens do we have in the last one? 3 nitrogens, very good. How many hydrogens? 12. And then, of course, 1 and 4, right? Those are going to be your ratios to do some problems, okay? Any questions about counting moles of atoms? If I got a mole out in front, then we would just count how many we have and distribute that number through. Okay? So, these are notes, and so these are two I would like you to write down so we can practice this problem to see how it works. So again, when you go from moles of oxygen to moles of the compound, it's a 4-to-1 ratio. So you go ahead and do the next one. You're going to go ahead and say, for every 1 mole of aluminum nitrate, that's the name of it, you guys will learn how to name these compounds later, you're going to have 9 moles of oxygen. Okay, so what was the answer on that? That would be what?
2.277.
So we'll go 2.28 moles of oxygen. Got it?
Yeah.
Okay. Now, we're going to look at finding number of molecules. So what you guys did on an assignment where you were given moles and you had to go to atoms is the same exact thing as we're doing here. Okay? Same exact thing. So I'm going to set it up and I'm going to go, if I got 7.35 moles of carbon monoxide, that's CO, then what unit goes down there? Moles of CO, right? Now we're looking at molecules. So up here, it's the same as atoms. It's the same as any type of particles. So up here would go what? Molecules. So what number goes in down here? 1, and then up here goes, yep, 6.02 to the 23rd. Remember, October 23rd, we're celebrating Mold Day. See how much we use it? Okay, so when you do that calculation, you just take 7.35 times 6, and then you add on your times 10 to the 23rd. And then you may have to adjust it if it needs adjusting. So that would be 44.2 times 10 to the 23rd, right? So what would that be in a correct way? 4.42 times 10 to the 24. Okay, that's all you have to do. So I'm going to have you do one of those.
We do that one?
Yep. So now you're going to go ahead and go from molecules to moles, though. This one I did for you, did from moles to molecules. Now this one's the reverse of that, and you're going from molecules to moles. But you still use the 1 mole and 6.02 to the 23rd. So go ahead and do that last one. Time it down. So, we have 7.35 times 10 to the 21st molecules of N2. So down here we go molecules of N2. And up here we go moles of N2. So what number goes down there? 602 to the 23rd. And up here goes 1. And so we're just going to divide that out. It's going to be 21 minus 23. So that'd be a minus 2. And that would be our answer to the minus 2. So it'd be 1.22 times 10 to the negative second, or 0.0122. Okay, so we're continuing using this for atoms and molecules, grams off the periodic table, 1 for moles, unless it's a conversion within the actual setup. So, what you're required to do for Thursday is on the board. Page 198, 468, and then 205, 22AB, and 26AB. You will turn this in on Thursday. I may add a couple molar mass problems to this, so if you're gone tomorrow, just double check on Google Classroom. What time do you guys play? 11:30, and you're not doing anything, right? If you lose, do you play that same day?
We'll play Thursday.
If you win, you play that same day. Right. So if you win, then you play later in the afternoon or evening that day. Is that right? So you guys will have a lot of free time since you're there Wednesday, Thursday, Friday. Because I've been there and done that. There's a lot of extra time there. If you get a chance, you guys got your phones. That's all accessible. What we go through tomorrow in Molar, Mass. You can do that. Be a student athlete, right? So if they call you a student athlete, students first, right? They don't say athlete student. They say student athlete. Okay?